starting from the origin, a quick overview. I won't go deep into any of those individual topics, but we'll see how the databases have evolved over a period of time. So we're primarily stressing around the period of 90s, right? Followed by that, we'll do a quick overview about the different types of NoSQL databases, and then we focus on MongoDB. So it'll take some time by the time we actually start the MongoDB technology. Then once we get started, we'll see. I didn't get a chance to ask you whether you're from Windows or Linux background, but MongoDB is supported in both the operating systems. So I would quickly show you how to install Mongo database in Windows and Linux individually, or as a service. Also we can install it. So we get started with the installation part, and a lot of binaries which are available as a part of the software. A quick introduction about the binaries and how they're useful. Followed by that, we'll go through the CRUD operations. So just like every relational database, we have a query language which is a JSON style, JSON based query language that we have. So we will be performing a lot of CRUD operations. Followed by that, in order to perform functions, we have the concept of aggregation in MongoDB, and aggregation further has three different types: aggregation pipeline, MapReduce, and another category. So we'll cover all the queries in that topic, and we'll have an introduction about data modeling. Followed by that, we'll go through the indexing concept. Like other relational databases, indexes are also supported in MongoDB. There are different types of indexes, right? So nowadays, a lot of applications, they are providing features related to data points like latitude and longitude of different places on the globe. So MongoDB also supports such kind of data. So there are geospatial queries related to it, and we'll be able to store the data and also enable indexes, geospatial indexes, that's what we call. So we'll also just go through those topics during indexing. And when we talk about MongoDB, we talk about performance, availability, and scalability. So performance is achieved because there is no concept of joins here. So we'll see how that is going to be useful. And regarding high availability, we have a concept called replication. So we'll see the model of replication, the architecture, how to configure replicas, what are the recommendations in terms of setting up replicas, a little bit into migration, from one version to another version, and you have a replica set performing rolling upgrades, etc. And followed by that, the high scalability feature is achieved using the concept called sharding, and we'll see different topics under sharding for each of the use cases, architectures. I would also be showing you a demo of how to set up a single node replica set, multi-node replica set, doing migration. Similarly, the sharded cluster, different components of MongoDB architecture other than the individual MongoDB instances. We have routers, config servers, etc. So we'll also do a quick overview about all those topics before we start configuring all of this. Then we have MongoDB native tools for performing backup restore operation. We can also do import and export of the data in MongoDB. And so this is using native tools which are available with the software. And other than this, MongoDB also have their own proprietary software available, or on premises we call it as Ops Manager. If it is on cloud, we call it as a Cloud Manager. So there are a lot of tools. So we'll go through some of those tools on how to quickly set up these tools and check the functionality which is available with these tools. And finally, we would go through some best practices and recommendations in terms of performance tuning, and monitoring MongoDB. So this is just a quick brief about the different topics that we'll cover in this course. So is there anything that you wanted to ask so far? You have any questions?
Very good.
Okay, thank you. All right, so starting with the first topic about the brief history of databases, why NoSQL databases, when can we use these databases, some introduction. I'm sure you're all familiar with asset-based properties and CAP theorem. So we'll quickly go through these basic fundamental topics which are necessary before understanding or before going into the NoSQL databases. All right. So I'm going to start with a quick question. Like, is NoSQL going to replace traditional databases? So that is one important question which I'm being asked in every training that I conduct. Is MongoDB going to replace a relational database, or is MongoDB going to replace an Oracle or a SQL Server database? So we'll get to the answer of this question by the end of this module. So let's get started. If this is a picture about history of databases, starting from the evolution of databases, right? And if you take the time around 90s, we are pretty much stabilized, and we have a very strong set of relational databases existing, right? And these relational databases have become so popular that we were using one or the other in every application or every use case that we had. So mostly you go, if you have a necessary investment, then you go for buying licenses for Oracle or SQL Server. If you're a startup, you might opt for an open source version of the database, which is a MySQL Server or a Postgres. So for every simple use case, we were mostly relied on these relational databases. So they almost lasted for around 10 to 20 years, right? So around 90s, the evolution of internet has started. A lot of people have started using internet, which has led to an increase in the data in different forms, right? So I'm sure you have heard about this data being evolving in three different uh, types, which is in terms of the volumes of the data, and then in terms of the variety of the data, and then the velocity of the data, right? So we get to this relational database. So first of all, focusing on these three. So as the number of people who have started making use of the internet, slowly the social networking applications have evolved, the underlying databases are facing challenges in terms of handling these volumes or the varieties of the data. Well, there were uh, the early companies who have started facing these challenges are ones like Google or Amazon, right? So these are the people, because a lot of people started making use of internet, performing online purchases, right? And doing a lot of searches in Google and getting used to the internet culture. So which was in turn generating huge volumes of the data. So even these organizations initially were using relational databases in the background, but when they've started seeing these huge volumes of data, they have tried using an alternative approach, wherein instead of using one big box, right? How about using multiple boxes? So this is the first. So they have tried this model first, but what they felt was relational databases are not meant to scale over a distributed architecture. So at the time the relational databases have been developed, or they have come into the market, right? The people who have developed it, so they did not expect that in the next 20, 25 years we are going to hit these huge volumes and varieties of data. So the way they have architecture didn't fit this kind of distributed databases. So soon they felt that this is not the kind of experience they were expecting, or the kind of performance that they were expecting, right? So these are the challenges they have faced in turn. So what they did was, if you have heard about two research papers that have been uh, uh, come from these companies, Google and Amazon. One is about Bigtable, and the other one is about DynamoDB. Right. So these two research papers, when they have come out, so people started understanding more about how to start scaling their systems when they face all these three different types of challenges. Right. So at that time, uh, there was a meet that has happened, a meeting somewhere, and so some people who are working on, who have a lot of experience working on relational databases, could be developers, DBAs, right? So they have started, right, also feeling that for the kind of applications which are coming up, primarily social networking sites, they have started making use of these kind of applications on top of relational databases, and they felt similar challenges that it is unable to handle the kind of load that is coming up. So they have, the same set of people have also started thinking in a different way, and by looking at these research papers, so they have come up with their own architectures. There was a meet that has happened, and they have just generally coined a name called NoSQL. That's where the name has evolved. And the people who have attended that particular meeting are now primarily from these different categories of NoSQL databases that we are familiar with. So based on the model that has been released from Google and Amazon, so the architectures, the current architectures which you're going to see under different NoSQL databases are primarily MongoDB. That is how it has evolved. Okay. So if you take an individual, let's take a simple example, right? So if there is a database of a specific capacity, and as the load keeps on increasing, right, there are certain limits for each database, and it can only perform well as long as it has enough resources available in terms of the disk processing as well as your RAM, right? Sooner or later, you're going to hit these limits. So at that time, you have two options left. Either you try to increase the existing capacity by extending the resources, or you have to move to a bigger machine, right? And moving to a bigger machine involves a downtime, and increasing the existing resources, right, would last for some more period of time. You can stretch for some more period, but as long as the application is doing well, as long as it is generating load, as long as it is generating data, then soon you are going to hit those limits as well, right? So you should prepare yourself accordingly. And it was not the case before, right? So it was not so easy before 20 years that in just 6 months you're gonna hit the limits of 50 GB. It used to take months in order to reach that sizes of the data, but now it is much easier, right? If you are running a social networking site, there is every possibility that if the application does well, and maybe in the next 2 3 months, there is a chance that you might reach those limits. So that's why, so these people have started using the different model which the Google or the DynamoDB research papers are talking about. Typically, in a relational database, right? It is so we when we talk about relational databases, we call for vertical scalability. So when we say vertical scalability, so you have a machine, and over a period of time you increase the size of the machine, right? Increase the resources, or you keep a bigger machine in the place of a smaller machine, right? So that increases the amount of resources, and at the same time, as you go for buying bigger machines, which are going to be very expensive, right? But as I've showed you, the way Google has tried, they do have a distributed architecture, and the people about whom I have mentioned, right? The people who have architecture NoSQL databases, before developing these products, they have a few things in their mind. So these are the people who have a lot of experience working on relational databases, and they have seen the type of applications which are evolving, coming up lately, and they have seen how compatible those applications are with the relational databases, and they have seen what are those areas which are not leading to the performance that they were expecting, right? So for example, as I've said, relational databases are not meant to scale as on distributed databases, right? So relational software. Similarly, uh, there you would find they are highly reliable on asset properties, and there is you need to perform joins in order to fetch the information. We have the concept of denormalization. So on top of that, there is a predefined schema with every database. There's a lot of work involved before inserting the data inside your database. So these are some of
Hey,
the areas.
Mark, can you hear? Just checking.
Yes,
Are you on slide 8? Because that's all we have to go off of is what slide you're on. So we don't know if it froze here or if you've been on this slide the whole time. Are you on slide
yes,
number 8? Okay.
yes,
Just
I'm on the
checking.
same. Sure.
Thank you.
Okay, so as I have mentioned, so these relational databases have some of these challenges which they are much familiar with, and they have been working on those areas. So accordingly, the architecture that they have developed, the kind of databases that have evolved, they made sure that these challenges are the features that are giving challenges, they are not being made part of those new models which have evolved. So what I mean to say is, so they have tried to remove, right? They have tried to develop the architecture in such a way that there is less dependency on the concept of joins, and there is less dependency on the schema part, right? So there is no predefined schema, something like that. And another important thing is, in the olden days, not in the olden days, but if you take relational databases, right, the kind of hardware that we were using, right, it's bigger, much bigger machines, and you have to spend a lot of money in order to get those machines. But all the NoSQL databases, if you take, they are capable of scaling on cheaper hardware, right? That means you can have very cheap commodity devices, commodity hardware, that's what we call them, and you can scale your applications on this set of parallel machines. Other than that, these all softwares, or these all the databases available are open source in nature. So when I say open source, a lot of people contribute to the open source community. In turn, they are providing community versions of the software, and at the same time, they also provide enterprise version of the same software, wherein you get enterprise level features, you get enterprise level support available from all of these vendors, right? So my intention behind talking about all of this is that if you take different sectors, different businesses in the olden days, right? We were using, let's say that there are 100 use cases, and we were using relational databases in all of the 100 use cases. And let's say that 90% of the use cases, right? For 90% of use cases, relational databases are the right fit. And 10% of use cases, we are using relational databases because we don't have any other alternative. Okay. Now, what happened is the moment when the social networking sites have started popping up, then they have they have contributed to this 100 use cases that I'm talking about. So that 100, let's say that it became 90, and we have 10% of the social networking sites altogether 100. So NoSQL databases, or the kind of technologies which are evolving in the database space, right? So they have taken that 10% of the market share, and the 10% which was there before, right? The 10% of the use cases where I mentioned that since there is no other alternative, we relied on relational databases. So only that segment primarily is focused when it comes to NoSQL databases. Still, there are examples or the applications where we still feel that only a relational database would be a right fit for. We should only go for a relational system, right? So it has the market has evolved in such a way that so relational databases still have got their own importance, and at the same time, the kind of based on the type of applications which are evolving, we have databases that have evolved accordingly. If you look at the different categories of NoSQL databases, right? So there we would understand that, okay, since we have these kind of applications, that's the reason. So they have come up with such kind of an architecture that would primarily focuses on these areas or the use cases. Okay, so for the question that has come up in the first slide, I hope you have understood what the answer would be. So there is no such thing as replacement of relational databases or Oracle with a database like MongoDB or any other NoSQL databases. It all depends on the applications which are evolving and according to technologies. So nowadays, if you see, every database is trying to come up with all the features. That means they wanted to support every kind of an application. So they're trying to slowly evolve in terms of their features so that they can get a little more of the market share. So that again we'll discuss later. Well, moving on to the next slide, I have already spoken about this, but when we talk about the variety of the data, right? So here there are different varieties: structured, semi-structured, unstructured data. Because if you take Facebook or Twitter, it's not just the text, but we share a lot of images, we share a lot of audio files, video files, right? So you would expect the underlying database to handle all these kinds of data, and at the same time, it should be good in terms of the performance. It should be good in terms of scaling the database over a period of time. So these are the three important parameters we keep asking, right? So we should be able to handle all the volumes, the pace at which the data is getting generated, the underlying database should be able to handle it. So all these are very important aspects. So looking into some numbers, I just randomly mentioned that. So like this, so the number of transactions which are handled at Walmart is around 1 million transactions. Facebook is handling 1 billion photos, right? And we are generating data in petabytes. So these are all kind of the challenges that we have. So that just in order to handle this, so we have just shifted from there is a small shift from relational side to the non-relational or the NoSQL database side, right? So this slide, I mean, in fact, I've already spoken about it, about the big table and the Dynamo, the research papers released from these two companies, and followed by that, how the NoSQL databases have evolved. And I would like to mention about one site here. If you're not familiar, it is called as dbengines.com. There you can see that there are a lot of databases. That means I'm talking in general, relational as well as non-relational databases. And if you observe the non-relational databases, the top three contributors are MongoDB, and then we have Cassandra and Couchbase, sometimes Redis, sometimes.
Kumar,
Yes.
can we move a little bit faster on these introductory slides? Thanks.
Okay, so moving on to the characteristics of NoSQL databases, as I've already mentioned, They are open source in nature, and we say that they are schemaless. In fact, they do have a different way of talking about the schema, right? And they are non-relational. They handle all types of data, and at the same time, they are cluster friendly. Okay, so looking into some of the other features of NoSQL databases, they are not in line with the ACID properties, and if you take MongoDB primarily, it doesn't uses the SQL querying mechanism. Okay, and it has also reduced the amount of the DB dependency in terms of setting up the databases. Okay, and there is when we talk about transactions, even the model has changed, right? Rather than having multi-document transactions, here atomicity is guaranteed only at an individual document level. All right, so these are some of the features that would focus more in the coming slides. Well, these are some of the examples or some of the companies who are using NoSQL sites, and talking about schemaless data model. So in relational databases, when you're setting up a database, right? So you have to define the things. In setting up tables, you have to define the rows and the columns. So what type of data that you're going to insert, right? So these are some of the prerequisites. But coming into NoSQL databases, right? So, Cassandra still is dependent on the schema. There is schema creation as a part of Cassandra, but primarily if you take Mongo database, right? So there is no predefined schema. We say that the schema is set up at an individual document level. So schema-less or schema is at an individual document level. It keeps evolving as insert more number of documents. So we'll see more about the schemaless data model when we perform some insert operations. So getting into different types of NoSQL databases, we have primarily 4 categories. One is key value pair. So key value based, if you have heard about Memcache, which is an in-memory database, they uses a key value model. Here, the data format is very simple, right? So that's the reason I would say comparatively this kind of databases have the best performance, okay? Because it has very less number of features and the data format is also very simple. Then moving on, we have a document model. When I say document, it doesn't mean a WordPad, PDF, or such kind of documents. So here we use a JSON style. JSON is the most preferred way because it is much compatible with all the languages, all the programming languages available. That's why it is preferred. And with JSON, we have different types of data structures. Maybe you can consider value pair being the simplest form. Your value in turn can have another key value pair, or it can have an array of elements. Your key and your value has an array of elements, and these array of elements in turn can be a key value pairs. So that's how you have a nested structure created out of your the JSON documents. So we'll see more about these documents. Then we have a columnar family. Cassandra is one of the top leading performer. It has a columnar family. It does have row and column structure, and these columns in turn have a lot of data structures that can be developed internally. Then we have graph databases. Coming to graph databases, it's altogether a different database that primarily focuses on storing data, mainly which is in terms of relations. For example, if you take a family having a father, children, and their children have a lot of children, so all these are stored in the form of nodes, and we have relations present across these nodes. So if you have such kind of data, it is a graph database is more suitable because it is much faster in traversing across all these data points and generating data. For example, if you're looking for people who are in between this and this, age gap who are also related to someone else. So such kind of queries if you have, or you can take LinkedIn, where you keep getting recommendations in the right side application, right? That you're linked to so and so person through so and so company or school or college. So that kind of data best suits for the graph model. So like this, we have other vendors as well in this particular space who are giving the corresponding databases, supporting the corresponding databases. Well, I do have few more slides here which talk about each of these data models, but since you wanted to skip this introduction a bit, so I would like to quickly uh, move to MongoDB, an introduction about the MongoDB and the document model. Okay, let me just start with the software.
Hey Kumar, I have a question. So
Sure.
the graph you mentioned earlier is fully supported by MongoDB, right?
I'm sorry.
The graph that you mentioned earlier is fully supported by MongoDB. Graph part. The graph.
You're saying graph databases, the features of graph databases?
Yes.
Well, MongoDB is not a full-fledged graph database, but it has a few functions using which you can perform queries on data that I've referred when it comes to graph databases.
Okay, thank you.
Sure. Okay. So before going through the topics on MongoDB, just wanted to show you some links for MongoDB. So in case if you wanted to download, so this is the download site. So the community edition, and you have an enterprise edition. The community edition doesn't have some of the features like support for SSL or Kerberos, LDAP, and most of the tools are available with enterprise version only. So in case if you're interested to download, I would recommend that you go with the enterprise version. So it has all the supported features with it. And so next to it, you can see that here, based upon your operating system, you can choose the one. You'll get a form that you have to just fill with some basic details. And after that, it will give you two options, whether you wanted to download the archive or the server. So always go with the archive part because it contains different components. The entire end-to-end software is available in that. All the components are available in that particular part. Okay. So again, if you are looking for any older versions of the same, you can click on this archive releases there. So it's like all the softwares for different operating systems, everything's available there. So there you would find that MongoDB is available in two different formats. One is if you take Windows system, it is .msi installer, and it would also be available in a zipped format. And similarly for Linux system, it is available in, for example, if you take CentOS or Red Hat operating system, it would be in a .rpm file, or you may also get it as a gunzip format, TZZ format. Okay, so here I have one installer available. I thought I would just show you. So this is version 3.4.1, and I also have some other versions. No, this one. So this is Red Hat Enterprise Linux compatible 3.4 version. Okay, so these are the two versions that I have right away. So let me just start with the installation part. This is for Windows. Mine is Windows 8 with 64-bit architecture. Till 3.0, MongoDB was available with 32-bit architectures as well, but they have stopped from 3.0 because most of the systems nowadays that we use are 64-bit architecture, right? So they have stopped it, and at the same time, MongoDB cannot perform well on a 32-bit architecture, so it is not recommended. And slowly they have stopped providing that version as well. Okay, so I think.
So do
Sure.
we need to download the software into our laptops, or do you have some sort of a VM where we can actually copy and then play?
Well, I don't have the VMs, but if you can download it parallelly, it would be very helpful, very useful for you as well. We can work together.
Okay, no, from a for the lab.
Yes, you have to install it in your laptop. I do not have the lab from my side.
Okay. Okay, so yeah,
So,
if you could actually.
yeah, please.
So should we download from the site that you've shown?
Yes, I will.
And is it a server version? I mean, is it a lightweight or the full version?
No, it is the full software. If you want to know what would be the size, it should be around 100 plus MB.
Okay. Yeah. Thanks.
If you can install it in your laptop, maybe I can help you. I mean, as in when I show you a demo of something, you can also try the same and let me know if you have any errors. That would also be, I mean, you can have hands-on parallelly. Okay, so coming back to this, I'm just trying to set up MongoDB in my Windows operating system. Well, it is already installed. I'm going to quickly remove it and install it again. Okay, here in this particular screen, so there is an option called custom. Okay, so if you click on custom, you can click on this drop down. You see there are different components of the software package. The first is server. So we can compare this with, if you're familiar with MySQL, we have MySQL D. That's the database server binary, MySQL D. Similarly, here we have Mongo D. That's the server binary. And then we have client. This is Mongo, like MySQL. And as I've told you, there are a lot of tools available as a part of the package itself. The monitoring tools, right? Mostly you have to use all of this on the command prompt. So we have Mongo stat and Mongo top in order to monitor the performance of MongoDB instance or the cluster running in your system. And then in order to perform backup and restore, we have 4 different tools: import, export, dump, and restore. We'll see examples on how to perform these operations, exporting and importing different types of data as well. Then we have Mongo Yes. This comes when we start the topic on the entire architecture of MongoDB. So Mongo Yes is also called as a router or a load balancer. So that would help us in distributing the load across the shards in your cluster. Then we have some miscellaneous tools like bson dump, Mongo decrypt, and Mongo files, Mongo LDAP, oplog, perf. So just like if you take one example, say BSON dump. So all the files which MongoDB generates are in a BSON format, and if you want to read these files, the database files, then you can convert them using this command. You can convert them into a JSON format and read those files. So like that, we have different types of tools available. We'll go through some examples of all these tools later. So here, when you're doing the installation, you can choose to skip some components, but so I'm just showing this, but I would go with the complete installation. So the difference between the MSI installer and normal gunzip file is, so when you extract a zipped file, for example, Windows compatible zipped file, you extract, that folder itself contains all the binaries. There is nothing like installation, the separate installation process. If you simply extract it, you get all the binaries, and you start those binaries in order to start your database. That's all. And using MSI installer, what happens is, instead of extracting anywhere, this MSI installer is going to extract the binaries under C program files, and then you may have MongoDB server and version number, and then there you would have all these binaries again. The MSI installer would also try to add MongoDB as a service in the background, right? That means along with the system startup, your MongoDB server also gets started, but it is not the recommended process in order to start MongoDB, because we have to provide some arguments. So there are a lot of arguments that we have to provide. These are all command line tools, I would say. So to which we provide the arguments and get the server or the database started. Okay, so we'll go through the prerequisites. Well, as this process is happening, I would quickly take you to my Linux prompt. So this is CentOS or Red Hat 7.0. And here you see, this is my MongoDB Linux 64-bit enterprise version of the software. I have extracted it to this folder called MongoDB-3.4. And once you extract it, you would have, right? So this is the folder. I'll just show you what is there inside. And then bin. So data is the directory that I have created. Okay. And inside bin, you can see all the different types of binaries present. That's all. We extract it, and after extracting, we make use of the server binary, which is MongoDB, in order to start your server database. Okay. The same way, if you install it using an RPM, usually whenever you install a service using an RPM, what happens is it would automatically be considered when starting up your system, right? So you can do service MongoDB start, service MongoDB stop. You can use it as a service, right? In that particular model. But we will be using it. I mean, we will be starting the database just by extracting the zip file. Okay, I'm done with the installation. So we go through C program files, MongoDB server 3.4 bin. Okay, so they're all directories that I have created. I'm just clearing those. Okay, so this is all what you would found, and there are some more files. Well, you can just focus on the binaries which are available. You see here MongoD, MongoCrypt, Mongo, JSON dump, and there will be some DLL files installed along with the default binaries, and prior to this, you would find these README files along with the software. So even if you extract MongoDB package, you would find the same. All right. So the installation process is very simple. You just extract it, and then we have to start the MongoDB server process, which is MongoD. Okay. This is my Linux system, and I'm inside the bin folder, and here if you observe, there is a folder called data. Okay, so it need not have to be the same name. You can create any directory, any folder. So basically that is a prerequisite for MongoDB. In order to start MongoDB server, you have to create a folder and give that as an argument. Okay, so in this case we have I'm creating mkdir, let's say Mongo data. That's the directory. And then in order to start Mongo database, excuse me. So this is the minimum prerequisite. That's how we start Mongo database. Okay. So this would start the database service in this system. So along with the database part, the reason why we have to give this folder is MongoDB will try to store all the database files inside the folder called Mongo data. Clear? And along with creating all the database files, MongoDB also generates a lot of verbose, a lot of logs. So if you do not specify a file name, it will try to print everything on the screen. So that's the reason I specify a log path, maybe the same place. You can give, there is no convention, right? Any specific naming convention is not there. So I just randomly give it as mongo.log. And as you all know, every service runs on a particular port number. Every service has a default port number. The server and the client communicate over a port number. So MongoDB also has a default port number. It is 27017. So if you do not specify any port, MongoDB will try to start on the port 27017, provided there is no other service running or using the same port. Okay, but as I have mentioned, it is the default port. Still, I'm just using it as a convention, right? Even if I do not mention this, MongoDB would still run on that particular port. And I'm going to run this process in the background by keeping an ampersand in the end. So this is the Linux style of running processes in the background. Okay, there is some dependency error here. It's okay. Just showing the same here as well. It is not mandatory to run MongoDB server as an administrator. It is not mandatory. You can also run it as a normal user. Okay, and then we have MongoD.exe hyphen db path. I created data hyphen log path, and I say mongo.log. Okay, so in a Windows system, if I run this, I won't get the prompt back. Okay, so in order to ensure that it is run in the background, we can give arguments like this: start space /b mongodb.exe, mongodb.exe, and then db path where the data is stored. Then we have a log path followed by port number 27017. So this starts MongoDB server. Okay, so we have like MySQL, we have started MongoDB. The database is running in your system. Okay, and we can cross-check this by going into the task manager. So this is one way, or you can also try connecting to that particular port. That means MongoDB is running on port number called 27017. Okay, so with the client,
Hey,
we will try to
Kumar,
connect.
one question. Kumar, one question. So, all the data gets stored into data directory, right?
Yes.
Since the directory is specified. So, do we have option to actually distribute among multiple directories?
Yes, it is possible. There is
Okay,
an
so
argument. Go ahead.
go ahead.
What I'm saying
No, go
is
ahead.
you can distribute the data, I mean, per database. So we have just started one database instance. Okay. So when you connect to that instance, there will be multiple databases that you can connect. So you can choose to have one directory per database. That is possible. So
Okay.
here
So, but
I will
is
show
that
you all those options. Yes.
yeah? So is that the standard, or can we have for one database, can we have multiple directories? Because if in Linux, if let's say the file systems are distributed across multiple storage boxes, so in that case, for one database, can we have multiple directories for the data?
When you say one database, you mean one database instance. So here we have
Yeah.
created data, right? Instead of data, you want to have multiple, for example, data one, data two, data three, like that, three different folders. So what I'm saying is you can have it, but again, each would be limited to a specific database created inside. You cannot have, let's say, uh, data one directory filled. Once it is filled to some 20 GB, and then it starts using data two. That you have to again reinitiate it.
Okay.
So now, okay, this is a MongoDB instance that I've started. Okay, so I connect to this instance like this by specifying the port. Let me be a little bit more clear. So now I have connected using a client Mongo. I connected to the server, database server, which is mongodb.exe. Now after connecting, I run a command show DBs. Here you see there are two different databases. So what I'm saying is you can have one directory. I mean, we can have one data directory for admin. You can have one data directory for local. Like that, for all additional databases that you create, you can have one data directory.
Okay.
Is this
So
what you're looking for?
is admin and local, are they subdirectories under data?
Correct.
Oh, okay.
So once we are done with this, so you can see here, well, these are the collections that you see. So I'll talk about these data files later. So these are the files where these are actually the files that get generated under the data folder. Okay, so coming back, I hope this part is clear, like how we have started the database. So we provide a few arguments. The important one is DB path. That's where all the data files will get stored. And then if you miss log path, then all this log information will get printed on the screen. Let's just take a look at mongo.log. So this is the log file. So I would suggest you start looking into these log files from the beginning itself. When the moment you start your database, parallelly we will start looking into the logs as well, right? So MongoDB has started with a specific process ID and the port number. This is the default port, and the version of MongoDB, the architecture, and the DB path, some of the arguments that we have given. Here, there is a word called white tiger, that is the default database engine which is used with MongoDB. So MongoDB supports different database engines. So prior to 3 it was mmap v1. By once, after 3.2, from 3.2 they made white tiger as the default database engine. We'll get into the details of both of this later. For now, white tiger is the default database engine. Okay, and plus whatever it has done as a part of starting Mongo database. So all this information, this is what I refer to as verbose. It is stored inside the log file if you specify it. Otherwise, it will print everything on the standard output. Okay, and like this, as you have seen here, there are different arguments that we pass with MongoDB. So here you can see these are all different types of binaries, right? For every binary, let's say MongoDB.exe. Let's start with. So you can do --help to look at the list of all the arguments that we pass to MongoDB, or list of all the arguments that are supported for MongoDB, right? So let's quickly go through some of the important ones. So here you can see that -f is an important argument. H is for help. If you want to know what is the version, -version. And you see verbose here. You can go for a maximum of 4 Vs. That means that would generate more verbose information when you are starting MongoDB, right? So the default we start with, we do not specify it, but still it's -v. But if you want, you can add multiple Vs that generate more information. Like that, some more important arguments for the initial period are, if you want, you can bind your instance to a particular port, right? To a particular IP address, I'm sorry. So when you bind it to an IP address, when you're starting Mongo, the client, right? So then you have to specify the IP address and the port number together in order to connect to your server. Then you have log path. You see there is an argument called log append. So here, in case if I stop the server now and I start it again with the same set of arguments, what it would do is the old log file which is there, it will add a timestamp and it will move it, and it will create a new log file with the name I have mentioned, right? So every time you stop and start, it's going to rotate that log file. So if you want to avoid that and have the same log file, you can use log append. Okay, and then some log rotation feature is there, then -auth. So by default, authentication is not enabled for Mongo database. Okay, so unless you connect it for the first time, create a user, mostly an admin user, and then you enable authentication. So going forward, it will ask you to provide the credentials, username, password, in order to connect to the database. So that's where, I mean, this is, so once we are familiar with connecting to the database, then we move on to enabling the authentication for MongoDB. And then going down, so for high availability, we have a concept called replication. So with respect to replication, there are a bunch of arguments that we pass. When we reach that particular topic, then we start MongoDB as a replica member. We will be starting different members of the replica set. Similarly, there is a concept called sharding. So when we reach the topic, we will try to start MongoDB instance as a shard server. Okay, like that we start different types of shards as a part of setting up the cluster. MongoDB has an inbuilt support for SSL in order to encrypt the communication between the server and the client. MongoDB supports encryption for data on the wire as well as data at rest, right? So in order to have encrypted data over the wire, so SSL is supported. So we will see an example on how to create a self-signed certificate and make use of it in order to have SSL enabled and the communication encrypted. So we'll see an example of this as well. And then Coming to the storage part, as I've told you, by default it starts with a storage engine, which is White Tiger. But if you want, you can make MongoDB start with the previous storage engine, which is mmap v1, which stands for memory mapped type of database engine. You have to pass an argument called -- storage engine. Then it would start Mongo database with that storage engine. So we'll also see an example of this by starting MongoDB using mmap v1. Okay. And like this, we have some options for White Tiger, and MongoDB has also claims to be an in-memory database. It has features to act as in-memory data store. So there are some options with that. And as a part of all the security features available, like authentication, and then Kerberos-based authentication, Active Directory, and one of the most important part preferred in the banking sector is auditing. So it is possible to enable auditing. Different types of admin activities which are done on MongoDB can be logged in an audit log file. So that's the importance of this. So you need to start the server with the corresponding options. So every feature that you see here, right? If you want to enable that feature, you have to pass the corresponding arguments. Like as I've told you, encryption of data over wire, and then encryption at rest. You can encrypt the files on the disk. Then you have Kerberos related. So like this, these are different categories or features supported by Mongo server, Mongo database server. Okay, like this, for every binary which is available, you can simply do Mongo-help in case if you find anything challenging, if you are unable to run something, you can quickly go to the help option where it would list all the supported arguments. So you should be using those arguments. If you are using a community version of Mongo database, then you may not find some of these options. As I've told you, SSL, Kerberos, some of these features are not supported. SSL, you can build it. That means you need to take the binaries, not the binaries, the source of MongoDB, and you have to build it with the SSL feature if you want to have that in the community edition of Mongo database. Okay, so this is a quick introduction of Mongo database in terms of giving a demo. Linux -- fork command is supported. So whether we use either fork or we can use an ampersand to run the process in the background. And a data directory is the prerequisite. By default, if you do not specify, then MongoDB won't start. So in the beginning days, there would be two types of errors you might face. One, maybe you have not declared the data directory properly. Number two, maybe you have already started an instance running on a particular port and you are trying to start another instance on the same port number. So these are the two common errors, and you can check the corresponding error messages in the log file. It clearly says that an instance is already running or a data directory is missing. So when you are starting it, make sure you also look into the log files. Okay. All right. Now that I've started MongoDB server, so I try to connect it. So whichever is the port on which you start the server, you just have to connect to that particular port. Okay. So once you have connected, well, there are two different ways of stopping the database. One, you go to the task manager, you choose the process, and you end task, right? Or in the Linux machine, you get the process ID, kill -9 process ID, and the process gets killed. So that is one way, and the preferred way would be doing a proper shutdown. And the way you do it is once you connect to Mongo server, right? So by default, it would say here that you are connected to test database. So if you type DB, it would say that by default, if you do not specify the name of the database, right, then it will connect to test database. Admin is the default one. It is created, switch to admin. So use space admin, and then you can do db dot shutdown server.
Hey Kumar, quick question. So when the database is started, do you also specify the language settings, or does it take whatever is specified on the operating system?
I'm not clear about
language settings. So, I'm talking with the language settings where the default could be Western European or or UTF-8, right? So if you have to explicitly specify, is it do you specify when you start the database?
Well, I haven't tried that option before. I need to check on that. Let me check and get back to you on this.
Okay.
1 second, I'm just making a note. Okay. So here, as you can see, I did use space admin. So when I do use space admin, I get moved to that database, right? So from test database, now I am under admin database. After coming to admin database, you have to run a command called db.shutdown server off. So here S is capital. So when you run this, automatically it is going to shut down the server process. Well, server is down, but it is still connected to the prompt. Okay, so it is connected to the prompt doesn't mean that the shutdown process is not successful. In order to cross-check, you can exit and try connecting again. Then it will throw that actual error message that the server is down. And the reason behind why it is still connected to the prompt, it is because in case, assume that you have two terminals open. In one terminal, you start the server, and in another terminal, you connect to the server using the client. So when you run shutdown server, it would still be connected to the prompt, because in the other terminal, if you start the server again, automatically the connection gets refreshed, right? And you're connected back to the server using the client. So that's the reason why you're still on the prompt. But you can exit and cross check. So it should fail. You should not be able to connect again. So this is the way in which we shut down Mongo database. This is a proper way of shutting down the database. And the reason why I mentioned this is, well, sometimes even if you kill it using the task manager or using a kill command, it works. But there is a chance that the underlying database files might get corrupted. If at all that happens, then you might have to, start it from the beginning, right? Your database may not get started. So that's the reason we perform a safe, proper shutdown using db.shutdown server command. So this is how we shut down the server. Now,
hey Kumar, quick question. So I see that the commands are in mixed case. So is it case sensitive when we execute these commands?
Yes, it is.
Okay.
So the next important thing is regarding the way we are starting MongoDB. So you have seen here MongoDB.exe, and I'm giving all the arguments which I feel are necessary to start the database, right? So this is one way of starting the database. There is another way in which you can start the database, which is by keeping all the arguments inside a configuration file. Okay, so you put all the arguments inside a config file and you pass the config file as an argument to MongoDB. Let's say I've kept all these files in a config file. Okay, then what I do is -- config, and I specify the path, and like this. Hope it makes sense. So automatically MongoDB is going to read all the arguments from the config file and it's going to get started. So this is the second way of starting Mongo database. It's totally up to you how you want to start. But one thing to remember is, for every MongoDB instance, Mongo database instance, well, we are going to, I'm going to show you setting up this instance that you have seen. I call it as a standalone instance. I would be creating a replica set in the same machine. I would be creating a sharded cluster with some 30 nodes in the same machine. So for me, it is important that I use one data directory for every MongoDB instance, a unique port for every MongoDB instance, right? So for if you are planning to create multiple instances, make sure that you have multiple data directories and multiple ports. And if we use this second convention of specifying everything inside a config file, then you might end up creating some. I mean, depending upon the number of instances, you'll be creating that many config files, right? So that is another way. Or what you do is there are some common parameters. For example, log append. Log append is a common parameter for every MongoDB instance. Maybe you might prefer to put all those common parameters inside config file and the unique parameters on the command prompt. Let's say you see this, I pass the config parameters using this, and at the same time, what I would do is I would say db path is unique, so I wouldn't put that. So in that way, I would end up creating only one config file with common parameters, and rest of the unique ones I would put on the command prompt, like log path, right? Mongo.log, and then unique port number. These are the three unique things: data directory, port number, the log file. So I specify them on the command prompt. Okay, so using completely the arguments or everything in a config file, or you can mix both the ways. Use part of the thing in the config file, part in the command prompt. This is all about starting your database server. Okay, and connecting to the database and how to.
Hey, Kumar, we're back. We can get started. So the first is we need help for the installation. So we'll first try to install the MongoDB laptop.
Sure. So do you have Windows or Windows 3.4.9 is the latest. Windows 6.64.
Yep.
Click download. You might see a form that you have to fill. Once you fill it, you would find these two options: archive and then an MSI installer.
Yep. So I've clicked on the MSI and then it's starting to download.
Okay.
Yeah, so download it, and then we're installing
Yeah,
now, and I'm doing a complete install.
yeah, please.
Yeah, so a couple of us went out for a meeting, so they do have MongoDB installed. So it's just me and Ben now. So yeah, I've completed the installation. Now to start, should I go to Windows command prompt?
Yeah, before that, just wanted to mention something. If you were checking my screen, something called services.msc. So if you open that, you would find, since you have used MSI installer, it will get installed in your system as a service. So that would be here. You can see these are all the different services which are present in your Windows system. And here it would be in an enabled state, right? I want you to disable this. So every time you
Yeah,
start your
so I don't see that. I don't see MongoDB in the services.msc. I did install through MSI, and I do see MongoDB files in the program files, MongoDB server 3.4/bin.
okay, fine. If you don't see it, let's go back to that console. So just for the sake of convenience, what you can do is, so I'm suggesting that you create the data directory, log file, everything inside the bin folder so that it would be easy for us. You can avoid giving all the path of the directories if you create somewhere else. So you can just switch to the bin directory from where we can start MongoDB, as well as make sure you create the data folder log
So
file.
do I need to manually, should I create manually the data folder inside the bin directory, or should I create it directly? Okay.
Now, what I'm saying is, you see here, now I'm in this particular directory, right? So when specifying, I can say mongodb.exe -db path. If the data folder is there itself, it is much simple. Otherwise, I have to give the entire path. Let's say it is on my desktop. So I have to give C users, Kumar, desktop, data directory. So it becomes a little complex, right? So if you create the same inside bin, it is much convenient. And log file, it generates automatically. So just specify the name of the log file, any log file name.
And then should I press enter once I provide that?
After this, as I have mentioned, see here, let's say that if I press enter, right? So it will not give the prompt back. It will just keep running there itself. 1 second. db path -- log path. You see, I'm not getting the prompt back. So if you want the prompt back, if I press Ctrl C, I'll get the prompt back, but the server process will get stopped. So that's the reason I suggested that we put start/b in the beginning so that this process will run in the background for this terminal. So then I get the prompt back and I can use the client from here itself. Or otherwise, you should have to open another prompt. That's it.
Yeah, I see an error called failed global initialization, failed not open, failed to open C program files, MongoDB server
I'll
3.4
tell you.
bin.
So when you're opening the command prompt, right? So if you
Okay.
open the command prompt as an administrator, then automatically the Mongo process would have that authority to create files under the data directory. But if you create the command prompt normally, then MongoDB process will not be able to create files under data directory. So you can close that prompt and open it as an administrator.
Okay. Once I open it, I should do it, or click
Yeah,
on it.
once you command prompt right click administrator run as admin, then again you switch to the bin directory, C program finds MongoDB server bin, and your data directory would be there. So you can just run it once again.
Yeah, it returned the prompt, but it did not actually give me any message actually as such.
No, actually, the message that you see here on my screen. So I was about to talk about this next. You remember I mentioned about log append. So log append,
Right.
what it does is every time you start the server, if you do not specify log append, the previous log file which was there, it will move it by adding a timestamp. That's what this says. You see this, the log file previously moved to mongo.log with a timestamp, and it freshly creates mongo.log and it will take it. So since you have started it for the first time, there was no log file before it has started. So what you can do is you can now connect to the server by saying mongo.exe space hyphen hyphen port. If you have not specified it, then it would be 27017.
Okay.
You able to connect?
Yes, I am able to connect MongoDB.exe port 27017.
Great. So here, please do observe that it says, it talks about MongoDB server version 3.4.1, Mongo shell version is 3.4.1. Right? You can also use a different shell in order to connect to MongoDB. But if you want to check where you can get this information, this is the first place. There are other places as well. Right? So once you are done connecting to MongoDB, so I request that you just take a look at your log files. So if you go inside C program files, main is this server 3.4. Here you have data directory. So as I've mentioned, White Tiger is the default database engine. So these are all the files that end with .wt extension.
So I opened the log file in. There's a warning in that log file says access control is not enabled for the database. read and write access to data and configuration is unrestricted.
Yeah, that
So
you can see on the command prompt itself. So there are some prerequisites when you start a database, right? But as of now, we have
right.
just started, so we have not done any such kind of changes. For example, when you create, usually it is not recommended to start the database as an admin or a root user. So you have to start it as a non-root user. So when you start it as a non-root user, then you would have limited privileges on your file system, and you would, whatever data directory that you create, right, we have to restrict that directory to that user only. We change the permissions, and similarly we try to enable authentication. And then also with respect to the number of with respect to firewall changes or number of open files, there are a bunch of parameters we have to configure our system accordingly. Then you wouldn't find all these warning messages, but that's okay, we'll handle this later.
Okay. Yep.
So you have gone through the log file, great. So now a few things. So we are connected to MongoDB server using Mongo client. So always if we do not specify the database that we wanted to connect to, then it will connect to the test database. So what I do is I'll simply exit, okay, and I'll just specify it in a different way. I would say localhost colon test / port. Okay, the other way around. Sorry. So this notation which is there, this is going to be useful whenever you try to connect to remote instances, or there is an argument called bind IP address. If you use that, you might have to give your IP address or the host name here instead of local host. You can specify your IP or the host name. So whichever is, so this is the local instance where your database is running. This is the port number on which it is waiting for the client requests. And by default, we are connecting to test database. So DB. So even if you specify or do not, you will connect to the test database. If you want to connect to a different database, you can specify that at that particular place. Okay.
So
CLS.
yeah. So even if we have to connect to our local install database, we can use this syntax, right? Host name and port, and then
Yeah.
test
Yes.
is database. Is it a default database that's already present?
Well, MongoDB always tries to connect to the test database. As in, when you have connected, test doesn't exist. So if you run show DBs, you wouldn't find test. But MongoDB, if you just type DB, it will say that it is connected to test. The difference is, so test is temporarily present in your memory until you create something inside it. So if you exit again, if you move to a different database, let's say use admin, okay, I switch it to admin database, show DBs, test is not visible because it is temporarily created in your memory. Only when you create something inside the database, then both will get created together. The database and then the content inside it will get created together. Until that, it is temporarily created in your memory, and the moment you disconnect, it is gone.
Okay, got it.
All right. Okay, so the first thing I want you to try is, once you've connected, you can check what is the default database you're connected to, and then show DBS, show databases, and then switch to admin database by saying use space admin. And then we will try to shut down the database. Okay, so before we try to shut down the database, I wanted to talk about three different categories of commands in MongoDB. So these commands start with db dot, this is one category, rs dot, this is another category, sh dot, this is third category. So db dot means general database commands, all start with db dot. So we follow a JSON style of querying with the database. Okay, and in this style we have three categories of commands: db dot, rs dot, sh dot. db dot database level. When we start configuring replication or replica sets, when that topic comes, we use rs dot, commands related to replica set, rs dot. And then third, sharding. When we work on sharded clusters, we use commands that start with sh dot. These are three categories of commands in general, right? And all commands that start with db dot. So one of the inbuilt feature of Mongo shell, this is what we call it as Mongo shell. So we connect to Mongo shell. One of the inbuilt feature of Mongo shell is command completion. That means you can, if you just type shu, press tab, or you can call it as tab completion feature, which is available with Linux systems. It will complete the rest of the command for you. So other options available, other features of Mongo shell are db dot, press tab twice, db dot, press tab twice. You'll see all the possible commands that would start with db dot. Okay, similarly, I hope you got my point.
Yeah,
rs dot,
basically, yeah. So if we press tab twice after db dot, then it will show all the commands that's possible prefixing with db.
Yes, similarly rs dot and sh dot. And we can type a partial name and press tab once, it will complete it for you, provided there is only one matching pattern of that name. So now the commands are much simpler to remember. So if you forgot something, just press tab twice and get the appropriate one with the syntax. I always recommend that use tab as much as you can, because a lot of people make errors by typing the commands. They remember the name and they keep typing it, but you have the convention like lower and upper case, right? Syntax would be different. So here in this shutdown, S is capital. So now use admin and then shut down your server. Once you shut down, just try reconnecting to it again. I hope you have started your server on port number 27017. You can try starting it on a different port. We have around 60,000 ports available in the system. Well, if a port is not available, your server won't start. So you can just randomly take a port number other than 27017 just to start your server on a different port. So when starting multiple instances, we would be taking different ports, different data directories, different log files. So I would be passing -- port as argument. Let's take 37017.
Yeah, in the services, it does not show this MongoDB.
That's okay. You can skip that for now.
Okay. So we're
You
good.
done?
Absolutely.
You are able to
Yep.
shut down it. Start MongoDB
Yes.
server on a different port as well.
Yes. 37017. That's where we have started.
Sure. Okay. Now let's just move to the slides. I have a few slides I wanted to talk about. So this qualities of NoSQL databases. Among this, some of the ones that I have not covered are cloud computing. So all of these databases are cloud compatible. So most of the vendors like AWS, Google, or Microsoft Azure, they do support, having MongoDB clusters over the cloud. In a few minutes, you can set up your cluster and plug it to your application. And some of the other features of NoSQL databases in general, flexible data model, high throughput. So since you're handling huge amounts of data, you would be expecting a lot of read and write operations. And parallelly, you would expect low latency operations as well, right? And the last one is using commodity hardware, cheaper hardware compared to mainframes. So specifically to MongoDB, it is non-relational, right? So when choosing a database, if you're looking for a database where you can store data of different structures, then MongoDB is one of the possible option for it. MongoDB's queries, not only the queries, but the data is also stored in a JSON format, right? And internally it supports or it stores the data in a BSON format. So these are the two supported formats, right? Queries and storage is in JSON. Internally it would be there in a BSON format. So then dynamic schemas, we need not have to create any kind of schemas before storing data inside MongoDB. It's one of the main reason it is quicker to quicker to set up and also to connect to your system, and also it is developer friendly. So the point is to give that flexibility to the developer so that he can design the database as per his application requirements. So it is not like we go to a DBA team, ask them that these are our requirements, set up the database and give it to us. So there is no need for a DBA involvement, in fact, honestly. So then we have replication, sharding. These are the built-in features which would help us to gain high availability or data redundancy or disaster recovery. So these are some of the cases where we go for replication. That's how it helps. And sharding primarily helps to scale your cluster for hundreds of nodes, right? And so among these three features that I was talking, the first one being the performance. How we could achieve higher performance is because there is no concept of joins in MongoDB, and there is no predefined schema in MongoDB, right? Schema evolves dynamically, or we say that schema is defined at a document level. So the data is stored inside MongoDB in the form of documents. Okay, so when I say document, it doesn't mean a Word or a PDF document. A JSON document would look like in this particular format. So I just wanted to give a few examples. If you observe this data, right? So it's like key value pair. So if we just go into this format, so let's say x:1, this is a key value pair, right? And then where one is a number, an integer, then you can use something like this. So you can put a string here, or you can go for something like this. A key and a value in turn would have a key and a value, right? I'm just giving you all the different structures, data structures inside a JSON document. So these together form a complete complex nested structure. So again, you have x colon, inside you have y:1, z:2, and then let's say x containing, right, an array of elements about like this, and x containing an array of strings, x containing
So
an array
key
of
value.
key value pairs.
Yeah. So the key value that you've shown there, X colon, Y colon 1, Z colon 2. So that's again a key value. So you can actually nest it, and the number of levels can go any number
Yes.
of levels for the
Yes, it
key
can
value.
go. There is a limit. I do not exactly remember, but it is greater than 50. Around 50 nested levels you can have. I'll give you that exact number. Okay. So you can have
So if you
nested.
have something like a hierarchy kind of a data structure, let's say product hierarchy or customer hierarchy, then we can use this kind of a concept, right?
Yes.
Okay.
I hope you have understood these different data structures. Now we can quickly do a comparison, right? One second, I'll just give you an example. Yes. So here it's a simple example of a record, let's say, of a particular employee, right? It is distributed in multiple tables in a relational database. But the same, if you observe on the other side, what we do is we try to keep all the related information in a single JSON document. In a relational database, the data is distributed in multiple tables. And if you want to query all the information of a particular customer, for example, we apply a join and we get the information from all the databases. But in MongoDB, at the beginning, right, when you architecture the database there itself, you make sure that whatever data, if that is distributed, that expects to be distributed, can we keep all this data in a single place, in a single document, in a nested format. So here you see we have key value pairs. Wherever there are multiple key value pairs involved, we used an array of elements. So that's how all this related information is stored in a single place. So there is, I wouldn't say similar to joins, but if you need a little flexibility, so it is possible with the help of a concept called embedding and linking. We'll get into this later. So in the case of embedding, just an example, what you do is you can put a document inside another document. So that's how the related information. So rather than setting up a primary key, and storing it in two different places, you bring both and put it in a single document, one inside another. Or what you can do is you can create a DB ref, that's the reference containing the underscore ID of the different document. So we'll understand these two different types of alternatives which we have, just in case if you need a little functionality of joins, right? So that is available in MongoDB. And
Hey Kumar, I have a question.
Sure.
Regarding the embedded document, what is the performance when we do the embedded document? Let's say we have like 10 tables referenced together, and I need to put the other nine tables into one JSON document. How's the performance of that architecture?
Well, even though if you have nested documents, we have a dotted notation of querying the objects, and we can project whatever documents that we want. We can also create indexes on the nested documents. So I would say that the performance would be good.
So you mean that even we have like 9 documents nested in another document, so the performance will be not bad at all, right?
See, comparatively, if you take a very simplest form of the document, right, when you compare this to that, yes, there would be a small difference, but it's not comparatively not so different.
Okay.
Hey, Kumar, so this referencing to one object to another object, or one table to or one, I don't know, what's the terminology used. I'll use that concept as table. So let's say if you reference one table to another table using this approach, but if we have a multi-key concept. When you say multi-key, like, you know, when I join two different tables, I can use the primary key or I can use a natural key, right? Which means two different keys. And, you know, situations could be, there are situations where you might use a primary key to join two tables, or you could probably use a natural key to join two tables. So in those kind of situations, you know, if you embed one table inside another table, how does it work, you know, in case we have to use the other key?
Yeah, so basically it is going to be two different queries that you would perform. The first query, you get the ID of the other document, and then you perform another query on the other document. So this is what you have to do it in your code. That's how you call it.
Okay. So basically, you kind of do a lookup instead of a join.
Right.
Okay.
But still, we will get into those again. For now, I just gave an introduction of this and quickly about the comparison between RDBMS and MongoDB. So database, still called as a database. We start with database instance. When I say instance, MongoDB server running on a particular port. And when you connect to the instance, the concept of database is same. We can have one or more databases, as we have admin and local. Inside the database, instead of tables, we have collections. Collections contain documents. You have seen how a JSON document looks like. So that is one document inside a collection. Like that, we can have multiple JSON documents present inside a collection. Okay, and then as it says, the rows are also called as documents, and these individual fields contain the key values with different data structures. We also have the same concept of index here. There is no change. Instead of joins, we go for embedding or linking. And in MongoDB, we have a primary key. Every time you insert a document, automatically an underscore ID field would be appended or be added to that document. So that's the default behavior of the MongoDB database, and index is enabled by default on the underscore ID field. Okay. Other than that, we can apply other types of indexes, secondary and other types of indexes on the rest of the fields, but underscore ID is the field on which primary key is enabled. And in order to perform operations like group by, as I've said, we do have aggregation. Under that, we have aggregation pipeline, MapReduce. Aggregation pipeline is the most preferred way when compared to MapReduce, because MapReduce is more complex, and yeah, aggregation pipeline is comparatively much easier to implement. So that's about quick differences between these two concepts. So now that you have seen the differences, let's create some of the documents, or for example, some collections, tables, databases, collections, and documents inside. And let's look at what underscore ID looks like, and what is the default index enabled on that field, and some of those things connecting to the database. Okay, so now I have connected, as I've told you,
Kumar,
by default it
connects. Sure. Kumar, quick question. Sorry, actually, primarily we are a relational background, so there's a lot of questions that arise. So please, pardon our ignorance. So I have a few more questions. So in relational database, there are other possibilities such as union of two different queries, or performing a minus operation, subqueries, correlated subqueries, having a select over select. So there are many concepts. So can we do all of those different combinations in MongoDB, or is there any kind of limitations that you see?
No, subqueries concept is not supported here, and we don't have concepts like triggers here. And we cannot combine different tables. That's not possible. End of the day, so that is the main purpose behind this data model that we have seen before, right? So instead of distributing the data, we try to keep all the relevant information in a single collection, because we don't have some of the features wherein we try to link different tables. So since it has been kept in mind that we are not going to distribute the data in Mongo database tables. So that's the reason the concept is try to group all the relevant information, accordingly enable the indexes, accordingly perform the queries on that data.
Okay. So does this actually limit in terms of our, because, sometimes it could be possible that, when we design or when you start a model, you may not have everything to begin with, right? Certain times, you just start with a portion of it, and then you start actually expanding the model. So, if we have to keep everything into one single document, does it actually limit in one way? Or, if you have to expand the same document, how does it work in that case?
See, okay, so before that, let me just give you one simple example. So when it comes to MongoDB, so before, see, you are talking from application. I mean, you have started at the application model, then you're asking me about how we can do this in Mongo database, right? But ideally, the approach would be, take the database level layer first, understand what features are there, and if you feel that these features would fit a particular application's requirements, then you choose MongoDB. It is not the other way around, that I wanted to have an application with all these features. So can I implement this feature in MongoDB? So that is one of the recommended way when we choose MongoDB. Okay. And second thing, yes.
Okay, got it. Makes sense.
Okay.
So basically, we should actually, look at all the different features, understand, whether our use case is going to fit this particular case, and then go implement it. Okay, got it. Makes sense.
So coming back quickly, we'll see how to create some of these databases, collections, documents. Okay. So as I've told you, it's all about JSON style. Internally, it is stored in a BSON format because BSON supports additional data types. And by default, when you connect, it shows test. That means test is not created, but that's the behavior. So if you run show DB's, test won't be present. It is temporarily created in your RAM. So when does it become permanent? When you create something inside that database. Or take another example, use XYZ, right? XYZ database is not present, but it says switch to XYZ. So XYZ is created in your memory. And if you look show DBs, it won't display that until the point you create something inside XYZ. So when you create something inside XYZ, then the collection will get created together. The combination of database name and the collection name is called as namespace in MongoDB. So now I have switched to XYZ, so temporarily created XYZ. So what I do is db.create collection of. So inside, so this is the syntax, right? Inside, give a collection name, call, for example. So the collection got created successfully. So as I've told you, along with this, if database is not there, they'll get created together. So XYZ got created and show collections. The collection is also created. So DB to check the default database, show DBs, show collections. If you say use space database name, that is temporarily created in your RAM. And if you create a collection inside, both will get created together. And db.create collection will create an empty collection. It won't have any schema. Okay, next what we do. So this is like your table, db.call.findOf. There is nothing inside. a collection. In order to create documents inside a collection, right? I showed you some examples: x:1, x:string, x:, another key value pair. You can get started with all those. These are all different types of documents. So let's create one. db.call.insert of. Inside this x:1. So I have just inserted a document. This is one document, simplest form of document in MongoDB.
Yeah,
And
so
then
the bottom portion
as a
is not, Kumar, the bottom, I think, you probably ran an insert command, but it is not showing over here. I think, the bottom portion is getting,
no,
somehow we are not able to.
Still?
Yeah. Yeah, now we can see. I think, when you scroll down, then we can see now the insert. Can you actually click on that hide? Go to meeting, pro screen is sharing your screen. Can you hide it?
Yeah, I have done it already.
Ben, you may want to do it actually on your side. Can you do it? Click on that. Yeah. Are you able to click it?
I think we're getting some.
I have already done that. Do you still see anything at the bottom?
Yeah, now we don't see it. Now
Yeah.
we don't see it.
Okay.
Okay. Now we can see your cursor. Okay. Yep, you can go ahead now.
So as you can see, I created a database, I created an empty collection, and I created and inserted a document inside. And with every document, I just inserted x:1. This is the only field, but this is automatically created _ID : object ID with this. And this field, right, it is like a primary key. It is unique. This is the only field which would be unique. So I can insert. Duplicates are supported. So every time you insert, a new _ID field gets generated and an index is enabled on this field. So like this, you can try creating multiple documents. So this is one format. Another. You see, with every document, right, the number of fields can be equal or more. It keeps differing. It's totally up to your application, the way it generates the data. The database is not going to stop you anywhere. Whatever be the format, number of fields you can insert. Like this, you can start inserting different data types inside, and slowly we will also start creating nested documents. Would you like to quickly try these options in your system?
Yeah, we're doing it. So now when I insert 1, 2, 3, 4, 5, 6, that is sort of an array for that particular key.
Yes.
C colon. Yep. If we want to insert multiple rows, or let's say if you have to append a column.
We do have set different types of operators are there. For example, or end operator, push, pop, and then set, unset. So as a part of CRUD operations, we'll practice different examples for all of these operators. I would share some sample data with you all, and you can run the sample queries. Whatever sample queries I share with you, automatically we would have sample data created. And on that sample data, we will also practice all the different kinds of operators available in MongoDB. Okay. So if you are done with these queries, the next simple one is, I'm clearing my screen. I hope you are done. So db.call.find off. Now db.call.find one of. So find one basically returns the first document. Okay, and I'm going to insert another document. I'm going to say call to. You see this output. Your as you increase the number of fields inside the document, right? You will not be able to read the field properly. You'll not be able to read the document properly. So that's the reason we have a function called pretty-off. So when you are performing a search operation, so you did find off. So it's find off is like select star, but it is only going to print the 20 documents right on the screen. If there are 100 documents, if you do find off, it will give you 20 documents. And these documents are printed as they are stored. That means they are not properly formatted. They are not in a readable way. So for that, we have a command called pretty-off. So if you do db.call.find off, for example, okay. So when I'm performing a search operation, I can specify the key value as an argument. Did I miss? Okay, got it. I think it is collection 1. Okay, so this output, let me just show it once again. If I put pretty-off, so then the output will be in a readable format. So this is another function that would be useful in order to read the documents. So here there is a where clause that I've kept. So what I'm doing is db.select star from table call one where y is equal to a string, and the output I sent it to pretty-off so that it displays the output in a proper readable JSON format. So pretty-off is another function. If you do db.collection.find1, right, find one will print only one document. It will print it in a JSON style. So here, since the first document is very small, so okay, we can do call one dot find one of find O is capital. So find one also displays the output in the same format. Okay, so these are two important functions. Next, what we do is to understand the output of find command.
Hey,
Let us
yeah. Can you scroll up? Actually, can you show the pretty command? Is it like pretty? Oh yeah, now I can get it. Okay. So we have to use the the brackets,
Yeah.
the empty brackets. Okay.
Okay. So what I would do is now let us try to insert a bunch of documents. I'm connected to test.
So,
Show collections.
quick question on the find. So when we find something, so it's equivalent to where clause. You know, when you specify within the square bracket, within the brackets. Yeah. And then do we need to specify a key and as well as the value, or?
Yes. Key and the value you have to specify. You have to specify
Okay.
the field. So that is your where. If you do not specify, it's like select start from table. So select start from table where x equal to 1.
Okay.
So that's the
So
where
in
clause.
your,
So
yeah, can you run the same petty command once again on that? I have some question on that. I'm just trying to read, like, you know, the row or the document, trying to understand that. Yeah. So now, what is Z and X over here? Are they, you know, a separate field within that row?
So these are all different fields, okay? So underscore ID, Y, Z, X. Inside X, this is, so this rectangular braces, it always points to the array of elements. And here we have Z as a key, and then we have key value pairs inside.
So now if I have to specifically find the field Z, and then under Z there is one more field called Z colon 3.
Yeah.
Because,
so
you know, these are like, you know, fields over, like, yeah, I'm just trying to understand. So it has field, and then under that field you have another field with a value.
Correct.
Right.
We'll get to that. Yes, these are all, I mean, we'll use dot notation in order to query all the nested fields. So we'll get to that level. So for now,
no problem.
Take this, right? And I'll use a small for loop. I'd say for I equal to 0, I less than 100, I plus plus. So this is a simple for loop that you know, db dot. Another important thing. A collection, it is not mandatory to create a collection first and then insert documents inside it. So it is optional. If you want, you can create an empty collection, or you can create a collection on the fly. That means just specify db.test.insert of. So here test is the name of the collection. I'll just name it test call. So test call is the name of the collection. It gets created on the fly. So it's like now with the MongoDB, we give log path, log file name. Log file is not created, but we just give the name. Then it creates the file and adds logs inside it. Similarly, you can give collection name and then start inserting inside. It would automatically create the collection with documents inside. Okay, so I'm just trying to insert x colon I. So for I equal to 0, x colon 0, that it goes till x99. So db dot test call dot count of. This is another function to check number of documents we have inserted. Okay, then let's go for find once again. Find off. So when I run find off on a particular collection, and if the condition matches more than 20 documents, then a cursor gets opened. Cursor. A cursor stores the output of find command. So it's like when you do select star, if there are 100 documents, we see all 100 documents printed on the screen. But here what happens? The cursor will store all the 100 documents and it will only print 20 on the screen. Okay, and the cursor is still open in the background. And how long it is open? At the bottom you see type IT for more. I keep typing IT. You see next 20 are printed IT. So the cursor is open till you print all and it says no cursor. So this is how find command works with the cursor open in the backend if the number of matching documents is more than 20. Clear screen.
Can we control that cursor in application?
As I didn't get your point.
Yeah, so you
No,
mentioned
it only. Yes, in the application, yes, we have multiple options that we put. That is the projection part of your query. So accordingly, the changes will get applicable for all the documents.
I'm sorry, can you explain again? Because you mentioned about the cursor and when we do the find, and the cursor will be loaded by MongoDB based on the resource, right? And from
Yes.
our application, when we use the find from Mongo, for example, in Java, so can we control that cursor?
Yes.
Okay.
Yes, you can do it. It should be.
So we can like roll forward how many cursor. For example, I want to show like 20 record or maybe 50 record. So I can control that from Java, right?
Yes.
Okay.
And there are also some of these functions. Let's say find off. Okay. Along with that, you can say limit function like we have in SQL, and then so the find returns the first 20 documents. I skipped first 3 and then limited to the next 5. Okay. Now let's see some examples on some more operations like test call dot remove of. Right. So first, before doing a remove, let's do it on find x:3, so that you know exactly how many documents are matching, and then remove of. XYZ show collections. You can do db dot test call dot count of and then db dot test call dot remove of by specifying curly braces, which means match everything. This is how we delete. So I have given you the condition. Whichever document is matching a condition, delete all those documents. And then second case, delete the entire collection. And we are still in this database, show collections. Well, I forgot to mention, it supports your MongoDB, the command prompt, right? MongoDB prompt, it supports storing the history of commands. So you can just press upward arrow to get all the commands. You need not have to type every time. So now we still have 3 collections, right? And db dot can do drop database. Okay, now use admin show database.
Yep.